Hello viewers, today we are going to discuss how to tackle a very commonly asked interview question about designing parking lot system. When an interviewer asks such a question, you need to first understand what he actually wants and what he is looking in the candidate. And so, you need to discuss first all the requirements with the interviewer before directly jumping into designing the parking lot system. Since the parking lot system design is a very vague question, don't assume anything on your own, but specifically clear out everything with the interviewer during the first 5 to 10 minutes of the interview. In general, you need to understand following. When an interviewer is asking you such question, the very first thing he's looking at is how good are you at requirements collection. Whether you can clearly list out all the possible requirements and whether you can successfully scope down the problem into something which you can solve in 30 to 45 minutes. Another thing that the interviewer is looking for is your system design and especially object-oriented design skills. He is looking for how well you can design the whole system in terms of components and classes. How will you model parking lot system into different classes and objects? Identify constraints and design interfaces. How well versed are you in object-oriented design concepts like abstraction, encapsulation, inheritance, and polymorphism? Can you define the links and association between the classes and objects in your system? Another thing that you need to consider is that when you are designing a parking lot system, you should be discussing the design in terms of different design patterns. The design patterns are well-established solution to the most commonly encountered problems which occur during software development. These represents best practices used by experienced object-oriented software developers. This shows the interviewer about your experience in object-oriented analysis and design and provides a positive feedback to your overall interview performance. So the interviewer is looking for whether you can identify different object-oriented design patterns or programming patterns while designing the parking lot system. When you will be discussing your requirements for the parking lot system, the interviewer might throw some different requirements to you. For example, he can add 2 or more entrances or exits to the parking lot system. In case the parking lot system has 2 or more entrances or exits, the interviewer is also looking at how you can tackle the concurrency in your design. Sometimes the interviewer gave you requirements about selecting a parking spot near some entrance to see how you can figure out finding the solution for nearest parking spot. Another important thing that you need to understand is that this type of question is not related to designing a distributed system. And so you should not solve it as a distributed system design unless you have clearly discussed this with the interviewer in the requirement collection phase. If you try to solve it as a distributed system design, then the interviewer can interpret it as you have not sufficient experience to scope down a problem correctly. And instead of simplifying, you are overcomplicating the system design. So let's first collect the requirements. So the very first requirement is that you should like this video and you should subscribe to this channel if you haven't done that. Anyway, jokes apart, let's consider that we have a very huge parking lot. If you Google, you will find that there are many parking lots with parking sizes more than 10,000. For example, the world's largest parking lot is in West Edmonton in Alberta, Canada, which has more than 20,000 parking spots for vehicles. The Seattle SeaTac Airport has more than 13,000 parking spots for the vehicles. So we are talking about parking spaces in the range of 10,000 to 30,000. So the first requirement is big parking lots, 10K to 30K spots. These huge parking lots will have more than one entrances and exits. In our case, let's assume that our parking lot has 4 entrances and 4 exits. 4 entrances, 4 exits. The third requirement is the customers collect ticket at the entrances and the parking spot is assigned on the ticket. The fourth requirement is the parking spot assigned to a vehicle should be near to the entrance. So the parking spot should be nearest to the entrance. So what it means that if a customer is entering into the parking lot from this entrance, then the parking lot assigned should be the nearest from this entrance. and if another customer is actually entering the parking lot from some other entrance like this one, then the parking spot assigned to that customer should be nearest from this entrance. The fifth requirement is the system should not allow more vehicles than the capacity of the parking lot. So there is a limit or capacity, and we can assume simply that the capacity that we have in our parking lot system is, let's say, 30,000. The sixth requirement is that there will be different types of parking spot. For example, there will be parking spot for handicapped, there will be parking spot for compact cars, there will be parking spot for large cars, etc. So in our design, we will consider there are 4 types of parking spots, and these will be handicap parking, compact car, large vehicle, compact vehicle, and motorcycle. The seventh requirement is the system should support hourly parking rate, and the final parking fee should be based on the total time that a vehicle is spent in the parking lot. The customers can pay parking fee both with cash and credit card. So cash and credit cards, they are accepted. There should be a monitoring system as well. So the monitoring system would be responsible for monitoring how many cars are entering and exiting, etc. And of course, there could be video surveillance as well as part of the monitoring system. Now the last but very important requirement that most interviewers actually forget is that you need to design the system in such a way so that it can be applied for the installation of parking system for more and more parking lots with minimal changes in the code and design. This means you can take your system and apply it to a different parking lot, maybe for a different shopping mall parking lot or an airport parking lot with minimal changes, mostly related to the configurations of that new parking lot, describing the overall structure of the parking lot, the number of floors, the capacity, and the different types of parking spots that the new parking lot system actually support. So the basic idea is that you are working for a company which actually installs different parking lot systems. And so what you would like to do is you would like to have your one system designed, and then what you would like to do is that you just want to apply your system that you have designed and you want to reuse that system for the installation of different parking lot systems. And the only thing that you would like to now change is the configuration information. This is code reusability. Now if you check the online sources, you will find that they discuss so many different superficial requirements. But please note, if you discuss those superficial requirements, then an experienced interviewer can actually catch you there. For example, if there are multiple parking floors, let's say in Seattle airport where we have like 6-7 different parking floors, then the requirement that there should be a panel at the entrance of each floor showing the number of free parking spots available in that floor is a conflicting requirement with our other requirement where we have said that the parking spot will be assigned to a vehicle at the time of entrance. So we don't really need this requirement in our system. Why? Because the driver will already know the parking spot which is assigned to him at the entrance. So if you add a requirement that each parking floor should have a panel showing the available parking spots, then this is a conflicting requirement. Similarly, there are other online resources which discuss some requirements regarding, for example, the color of the vehicle. However, an interviewer can ask you how the parking system will benefit from such requirements. How knowing the color of a car actually helps in the overall design of the parking system. So you need to understand this thing, that during requirement collection, you should not discuss some superficial requirements with the interviewer, which are hard for you to justify that why you need them in designing the parking lot system. It also shows that you are not experienced enough to collect the right set of requirements, and you are overcomplicating the requirements instead of simplifying the requirements to come up with a simple design. We will design that parking lot system using some design patterns. There are 3 broad categories of design patterns. The first one is creational design patterns. The creational design patterns deals with how the objects are instantiated. The second type of design patterns are structural design patterns. The structural design patterns discuss how different objects and classes are composed in order to form larger structure. And the third design patterns are behavioral design patterns. The behavioral design patterns deals with the responsibilities of the objects and how they interact with each other. Before going into the design of the parking lot, we are also going to discuss the design approach that we will be taking to design the parking lot system. So there are two different design approaches that people usually take. The first one is top-down design and the second one is the bottom-up design. In the top-down design, we first construct the high-level object and then we identify these smaller subcomponents in it, and then we design those subcomponents, and then in each subcomponent we identify its subcomponents and then we design those subcomponents. Whereas in a bottom-up approach, we first design the smallest component and then we use those smallest components to design a bigger component, and so on and so on. Please note that the bottom-up approach is aligned with object-oriented design, and so we should be using bottom-up design approach while designing a parking lot system. At this point, we should identify different objects and actors in our system. So we have the parking lot system itself. Then we have entry and exit terminals. Entry, exit terminals. Both the entry and exit terminals will have printers. The exit terminal will also have a payment processor. Then in our parking lot system, we have a parking spot. Another actor is the ticket itself. Then we will have the database. We will also have the monitoring system. Let me know in the comments below if you think there are other actors as well which we need in our parking lot system. I will go further now into details of these objects. However, before going into that, I would like to discuss one other thing. If you have seen other online sources, you will find that they also describe vehicle as an actor in the parking lot system. And so in their design, they usually have a vehicle class, and then they derive different classes from the vehicle class like a compact vehicle, large vehicle, bus, truck, etc. Please note, a good interviewer will ask you a question that why even you need a vehicle class in your system, and why are you defining a vehicle class. He can ask you questions like how using a vehicle class helps you in designing the overall system. What are the different options or methods that the vehicle class need that are helpful for you in designing your system. So please understand the difference between a vehicle parking spot and a vehicle class. The parking lot system will be using the vehicle parking spot, but it will not be using a vehicle class, as there is no reason to use a vehicle class along with its subclasses. So do not define a vehicle class along with its subclasses if you don't have a clear story about their usage in the overall system. Now let's design different interfaces, classes and components in our parking lot system using bottom-up approach. So a vehicle parking spot is an actor or an object in our system. There could be different types of parking spot. Example, we could have a parking spot for handicapped, we could have a compact parking spot, we could have a large parking spot, we could have motorcycle parking spot, as we have discussed in the requirements. Now there are two different ways to represent those different types of parking spots. One way is to use enum types to represent each type of parking spot. However, this shows that you are not that proficient in object-oriented design, as this approach has some flaws. For example, if you need to add another parking spot type, then it could require changes at various places in the code, which would violate the open-close design principle. This principle dictates that existing and well-tested classes should not be modified when a new feature needs to be built. The second approach, which is more preferable approach, is that we actually derive each different types of parking spot from a parent parking spot interface or class. So this diagram shows all the different types of parking spot available in our system in terms of different classes. So we have a parent parking spot class, and which has an ID and reserve as a property, and there will be methods to get the property like get ID, and there would be a get and set function on the reserve property as well. And now if you see, we have handicapped parking spot, compact parking spot, large parking spot and motorcycle parking spots are different classes which are derived from this parking spot. And now in that case, if we have to add another type of parking spot, what we would need to do is just actually extend this parking spot class by some other parking spot class. That's it. Please note that the parking spot class will be an abstract class. What it means that we cannot instantiate an object of a parking spot. We could instantiate an object of handicap parking spot or large or compact parking spot or motorcycle parking spot, but not the parent parking spot class object. We will have parking ticket, where we will have parking ticket ID in it, parking spot ID. The ticket will contain the information about the spot or the parking slot number where the car needs to be parked, then the parking spot type, and the issue time, which is the time when the vehicle enters the parking lot. As we discussed in our requirement, that there are two types of terminals that we have in our parking lot system, which are entry terminal and exit terminal. And so we will have a terminal class which would have a get ID as the class function, and then from this terminal class we would actually derive two different classes, one for the entry terminal, one for the exit terminal. And you can see right now the entry terminal has get ticket and with the parking spot type, and then we have an exit terminal and which accept the ticket, and it's a ticket, it takes a ticket as input. And please note, when I'm saying classes right now, these are either abstract classes or interfaces which will be implemented later on by the actual class object. Now the next set of interfaces and classes that we will discuss will be related to the assignment of parking spot to a vehicle. So we will have an interface called parking assignment strategy. It will have a get parking spot function which will take a terminal as an input. This terminal is the entry terminal. So this get parking spot will return a parking spot, and then it will also have a release parking spot which will take a parking spot as input, and of course it will mark that parking spot as free or available again now. And now here we will be using the strategy design pattern, where we'll actually inherit our parking spot near entrance strategy class, which will implement the algorithm to actually figure out the nearest parking spot and return that parking spot to the entering customer, and it will be implementing this interface. So let's discuss the requirement again that we had about assignment of parking spot. So we discussed in our requirements that we would like to assign the nearest parking spot to an entering customer from the entrance at which the customer is entering into the parking lot. So pause the video here and think about it, what would be the best way to implement that parking assignment strategy. So a big part of your interview will be dealing with the assignment of the parking spot, and then based on the requirements that your interviewer has set in during the interview, the design would change. For example, how you will assign a parking spot when you have only single entrance. It's totally different from how you will assign a parking spot when you have two or more entrances. Also, how will you assign a parking spot when there is no such requirement about the nearest parking spot? How you will implement the strategy to assign a parking spot when you don't have any requirement to return the nearest parking spot, then to the strategy when you have a requirement to actually return the nearest parking spot is totally different. In our case, we have 4 parking entrances, and we would like to return the parking spot which is nearest to the entrance from where the customer is entering the parking lot. In my opinion, the best way to implement it is using min heaps. So we will have as number of min heaps as the number of entrances, and all the parking spots will be added to all those min heaps. So for each entry terminal there will be a min heap. So we will have 4 min heaps for each one for each entrance, and these min heaps will be actually storing the parking spots in an order of the distance from the entrance. Apart from that, we will have 2 sets of parking spots. One set is for available parking spots, and the other set would be for reserved parking spots. So at the beginning, all the parking spots will be available, so will exist inside this set. Now when, let's suppose we have these 4 entrances, A, B, C and D. So we will have actually a map of min heaps, where the key is the entrance ID and the value is a min heap. A min heap is a data structure which returns a value which is the smallest of all the other values in that data structure. So a min heap is a data structure which is usually implemented in terms of a binary tree, where each node has the value which is less than the value of all of its children. And so whenever you actually want to retrieve an object from the min heap, it will always return you the object which has the minimum value. And a min heap for one parking entrance will have the parking spots in it sorted in the order of the distance from that parking entrance. So now when the user calls this get parking spot, it will give us the parking terminal from where it is entering. Based on the terminal ID, we will retrieve the min heap for that terminal, and then we will just pop the element from the top of the min heap, which will give us the parking spot which is at the minimum distance from that entrance. We will mark that parking spot as reserved. We will also remove it from this set of available parking spot, and we will move it into this set of the reserved parking spot. We will also remove that parking spot from the min heaps of other terminals as well. This algorithm will have a computational complexity of k log n, where k is the number of min heaps which is equal to the number of entrances, and n is the number of parking spots in this parking lot. Now I have a question for you. Let's suppose if the interviewer changed the requirements. So now apart from these entrances, you also have, let's say, 4 elevators in the parking lot, and now the interviewer asks you to actually return a parking spot which is nearest to the entrance from where the customer is entering into the parking lot, and one of the elevator as well. So find a parking spot which is nearest to both the entering terminal as well as the nearby elevator. Let me know in the comment below how will you implement this requirement. We will also have a payment processor interface which has a process, function and amount, and it will also be using strategy design pattern, and this interface will be implemented by different classes which implement different types of payment processing. So for example, we could have a credit card payment processor which process credit cards. We could have a cash payment processor, and in the same way in future, let's say if we introduce some other type of payment, for example Apple Pay, we could actually add another class which will implement the same interface. This is also using the strategy design pattern. Apart from that, we would also have a tariff calculator, and this tariff calculator interface will have calculate tariff, and it will take input as the time and maybe the parking spot type, and will return the dollar amount that should be charged to the customer. And then we could extend this interface by different classes which could have different tariff calculation type. For example, we could have different tariffs for weekdays as compared to different tariffs for weekends, etc. We have discussed in our requirement that we also have monitoring system. That monitoring system can actually use the observer design pattern to actually introduce itself into different components within the system. So we could assume that, let's suppose our monitoring system has a logger interface which has a function like log message. So you need to understand that since we are using bottom up design approach, so first we will be discussing the design of individual objects within the parking lot system, and now we will construct the parking lot system on the whole system based on those small components. Now we will discuss the design of the parking lot system itself. So first of all, the parking lot system itself will have a parking lot class, and it will be using the singleton design pattern because there will be only one instance of the parking lot system itself. This parking lot system, which is a singleton object, will be composed of different smaller objects, and we have already discussed that those objects include entry exit terminals, parking spots, the assignment strategy, etc., the payment processors, and also the printers, etc. And we will be using the factory design pattern to actually instantiate all those objects. Now the implementation of the parking lot system class itself can take a configuration object as input, and this configuration object may have different values depending on the requirements of the parking lot. For example, the number of parking spots, the type of parking spots in it, the printer settings, etc., the payment processor settings, etc., etc. And then we can use abstract factory and factory design patterns to instantiate those objects and link them together. So in that case, in our overall parking lot system, we will have a set of terminals that we will actually instantiate. The set of terminals, that is the set of entry and exit terminals that we will instantiate. We will also instantiate a parking assignment strategy and will pass it a configuration object, and from the configuration object, that strategy instance will actually retrieve all the parking spots along with the parking terminals and the distances of the parking spots from each entering terminal, etc. We will also instantiate the different payment processors, and we will pass those payment processors to the exit terminals, because this is the place where we would be processing the payment. We will also instantiate printers based on from the configuration based on the printers in each exit entry terminal, and we will instantiate those objects and will pass those objects to those terminal instance as well. So this is how the overall system would be designed. So I'm going to stop the video here now. I'm not going to discuss and actually write all those class definitions in this video because it's beyond the scope of this video. For example, in the strategy class, we didn't discuss about how the concurrency will be handled, which we can easily handle through like some synchronization mechanism like locks, etc. The main thing that I wanted to discuss with you guys here was, if this design question come, what are the things that you need to look into before designing this, and what are the things you need to consider. The main purpose of this video was to actually give you some guidelines that if this question comes, how will you solve this question in an actual interview. So please do let me know in the comments below if you find this video useful, and also please do like the video and also subscribe to this channel if you would like to get notified about my future videos. Thank you and take care.
Hey guys, today we're gonna learn frozen princess and mathematics. But first we're gonna use mathematics. Plus 1 plus 1 equals
What?
11.